the interesting aspect here is what Taylor proved, that's what this is called Taylor's theorem, is that the polynomial that we have just seen is f minus the polynomial is small o of x minus a to the n when x goes to a, right? This is just the generalization of this this technique that we have been doing, right? So how do we prove this? The proof is easy, right? The proof, we need just to prove that the limit when x goes to a of f minus the Taylor polynomial, we write, degree n at a is going to be small o of x to the a minus n, x minus a to the n. This is equal to 0, right? Now again, we know that at a, these two are going to be the same, so we have to differentiate it, but then we have that, so we have to apply L'Hopital's rule, but the derivative of the polynomial, right, it's going to be, if you think about it, it's going to be start with f prime at a plus, and then we have f at a times x minus a, and then so on. Okay, so all of these terms are going to 0, and then you have f prime at x minus f prime at x. So this is going to be 0 divided by 0 again. So we need to keep applying L'Hopital's rule, and up until when you get to the nth derivative, right? The nth derivative of x and the nth derivative of the Taylor polynomial. And which this is interesting is that well, not the nth, sorry, the nth minus 1, right? The n minus 1. Okay, so then here, and then here, this is n times n minus 1 times n minus 2 times, you differentiated n times, this is n factorial times x to the a, sorry, x minus a, right? And now what is this, right? So we have the limit when x goes to a, and then we have the n minus 1 derivative of x, and then if you differentiate this n minus 1 term times, every term except the last two in the polynomial will vanish, right? So all the powers that's smaller than n minus 1 will vanish. So we have the first term is the derivative, the nth derivative with respect to x of x minus a to the n minus 1. So this is the right, and this is going to be n minus 1 factorial, right? If you do it again, this is n minus 1 factorial. So this is n minus 1 factorial that multiplies the term that's going with this, which is f to the n minus 1, sorry, the n minus 1 derivative at a, right? Now if we compute the n minus 1 derivative of x to the x minus a to the n, this is just n factorial times x to minus a, which is what we have done here, right? Now in the Taylor polynomial, the term that's multiplying x minus a to the n is f to the, so the nth derivative of n divided by n factorial, right? So we have, this is minus the nth derivative of a times x minus a. All of this divided by n factorial times x minus a, right? And so now we have that this is, we can take the factorial out. This is the limit, limit on, the n minus 1 derivative of x minus the n derivative at a divided by x minus a, and then we have minus the nth derivative at a, right? I'm just expanding these two things. But this, again, this is the definition of the derivative of the n minus 1 derivative, so this is going to be equal to the nth derivative at a, and this is equal to 0, which completes the proof.